Okay, today we're going to talk about special angle pairs. And just as a review, let's talk about perpendicular lines to start. Perpendicular lines are lines that intersect to form four right angles. So when you go to draw your picture, we're going to sketch two lines that intersect, which again means that they cross. But not only do they cross, but they cross and make right angles. You only have to label one. You don't have to label all four. We know that if it makes a right angle, then we know that angle equals 90 degrees, okay? So looking at example 1, they told us that line NP and line Q are perpendicular. So anytime you see that, you automatically get to go ahead and stick the right angle symbol in there. And they want us to classify two different angles and find the value of x. So let's highlight that first angle, NOR. So if we highlight angle NOR, we can see that angle NOR is a right angle. And classify just means, again, what type of angle it is. And that's the angle symbol. Then they want us to classify QOR. So if we highlight Q to O to R, we can say it's two right angles put together, and that equals 180 degrees. And so if you have an angle that equals 180 degrees, remember that is called a straight angle. All right, the last thing they want us to do is find the value of x. Well, they gave us that NOR is 5x minus 5, and we already determined that NOR is a right angle, so we can set 5x minus 5 equal to 90 degrees. And so we can add 5 to both sides. 5x equals 95. Divide by 5, and x equals 19. Okay. Looking at the next set, we've got some more vocabulary. Now, not all intersecting lines are going to form right angles, but they do have some special relationships that we have to talk about. The first one is going to be vertical angles. The definition is when you have two non-adjacent angles formed by intersecting lines. So the picture for that would look something like this. We have our intersecting lines. Okay. Angle 1 and angle 2 are an example of vertical lines. Vertical angles, sorry. If we shade those, you can see that they are non-adjacent. They are across from each other. We also have another pair here with 3 and 4. 3 and 4 are also considered vertical angles because they are non-adjacent. All right, the next word is linear pair. These are adjacent whose non-common sides are opposite rays. And so when we did the vocabulary the other day, we said that a ray or opposite rays are rays going in opposite directions. Okay, there's your opposite rays. But we have to create two angles out of that. So there's an example of creating two angles. We could say angle 1 and angle 2 are a linear pair. They are adjacent to each other. We can see that those shadings touch. And we can see that straight angle. They add up to 180 degrees. Okay, it makes a straight line. So now let's look at our theorems about these two angles. Very easy to remember. Vertical angles are always going to be congruent. So if we look at our picture above here, we said that angles 1 and 2 are congruent. They're vertical angles. And also angle 3 and 4. Both of those sets are vertical angles, so both of those sets are congruent to each other. Okay, 1 and 2 is congruent to each other, and 3 and 4 are congruent to each other. So when you're working with vertical angles through this lesson and throughout the year, you're going to remember the equation part equals part. They're equal to each other. They're congruent. So that is the equation every time you use vertical angles. The theorem for linear pair is that if two angles form a linear pair, then they are supplementary. And so remember that supplementary means that they add up to 180 degrees. So using our picture from above, we could say that angle 1 plus angle 2 equals 180 degrees. Okay? If you're going to use an equation to remember there, we would say part plus part equals 180. Okay, so those are the equations you need to remember for linear pair and vertical angles. And so let's practice that on the next few examples. looking here, go ahead and shade your angles first. Shade what was given so that you can determine, are they adjacent or non-adjacent? And we can see that these shadings don't touch, and so that makes them non-adjacent, making them vertical angles. We talked about on the last slide that anytime you have vertical angles, you will set up part equals part. And so now we can substitute what we have in for those two parts. I have 3x plus 15, and I also have 2x plus 20. Doesn't matter which one you put first, it'll all work out. So we can subtract the 2x, and I'm going to go ahead and subtract the 15 at the same time. And so if we combine our x's, we're left with 1x. If we combine our constants, we're left with 5. Now, the question doesn't say find x. It says find the measure of angle EBA. So if we go up here and highlight EBA, they're talking about this angle right here. So we can take our x and plug it in to angle EBA. So we know 2 times x, we know x is now 5, so substitute that in, plus 20, so 2 times 5 is 10, plus 20 is 30 degrees. Okay. Next one, go ahead and shade. We can see that our shadings are adjacent, making this a linear pair. And if we have a linear pair, we automatically write down the equation, part plus part equals 180 degrees. So plug in both your parts, 7x plus 20 plus 5x plus 10 equals 180 degrees. Let's combine our like terms. We have 12 x's. We have a 20 and a 10. And that gives us 30. We can subtract our 30 from both sides. And so 12x equals 150. And x is going to equal 12.5 when we divide. Okay, again, look at the question. The question doesn't say find x. It says find the measure of those two angles. So what do we have to do once we find x? Plug it in. So let's plug in over here. We can say 7, so angle LMO is 7x. So x is 12.5 plus 20, and that's going to equal 107.5 degrees. Okay, so that was LMO. Let's go ahead and fill that in. We can do the same thing with OMN. Angle OMN was 5x plus 10, so 5 times 12.5 plus 10, and that's going to equal 72.5 degrees. Now, you can take those two to double check yourself, add them together, and they should add up to 180 degrees. Okay, let's look at the next one. Again, let's do our shading. We have to decide, are they adjacent or non-adjacent? We can see they're non-adjacent, making them vertical. We know if they're vertical, we're automatically going to put part equals part. Doesn't matter which part we start with. I like to start with my bigger x. Okay, subtract your 13x. Go ahead and add 20 at the same time. And so we have 3 x's and 27. Divide by 3, x equals 9. The question says find the measure of angle JIH. So if we shade that, JIH is right here. Well, that wasn't one of our vertical angles, but we can see here that if we put these two together, we have a linear pair, and we know linear pairs add up to 180. So let's go ahead and find what this angle equals, and then we can subtract that from 180 degrees. So if we plug this in and say 13 times 9 plus 7, that's going to equal 124 degrees. So we know this angle is 124. And again, we said those two circled add up to 180 because they're a linear pair. So just take the 124 away from the 180, and that leaves you with 56 degrees. So always pay attention to what angle it's asking for. Use your highlighter tools to your advantage here. All right, some review vocabulary back from when you were in middle school. We have the sum of the measures of two angles is 180 degrees. We know that from that example, example 3. That is called supplementary, and we learned that in the linear pair definition. So supplementary angles okay, anytime you're dealing with any type of supplementary angle, we're going to use part plus part equals 180 degrees. Okay, when they add up to 90 degrees, the two angles, remember that is called complementary. And if we have an example with that, we would use part plus part equals 90 degrees. So just look at your keywords in the problem, and that'll tell you which equation to set up. So let's look at example 5 here. Angle 1 and angle 2 are complements. They give us those two measures. They want us to find the measure of angle 1. So if they're complements, that means they're complementary. So we plug in part plus part equals 9 degrees. Substitute our givens in. So angle 1 was 2x plus 20. Angle 2 was 3x plus 15. And that equals 90 degrees. Combine our like terms. We have 5x. Our constants, 20 and 15, give us 35. Subtract your 35 from both sides. 5x equals 55, and x would equal 11. Now again, we're not done because it says find the measure of angle 1. So we know that angle 1 was 2x plus 20. So we can substitute the 11 in for x. 2 times 11 is 22, plus 20 gives us 42 degrees. Okay. Now, let's look at this one. Here's a symbol here that we haven't talked about yet. But we really have, because in the very first problem we talked about the word perpendicular, and this is the symbol for perpendicular. So go ahead and stick that in your notes so that you remember what that symbol stands for. And from here on out, you don't have to write out the word perpendicular. You can use that symbol. And we talked about at the very beginning, if you were given that two lines were perpendicular, you knew that they formed a right angle. So if AB and CD are perpendicular, that means that angle is a right angle. And so if that angle is a right angle and it's split into two parts, those two parts add up to 90 degrees, making these complementary angles. Okay, if they're complementary, we'd said that every time we're going to use this equation. And so they told us that angle 1 is 6x minus 3. They told us that angle 2 is 7x minus 11. And they want us to find the measure of angle 2. So let's find x first. Combine your like terms. 13x. Negative 3 and negative 11 is negative 14. We add 14 to both sides. 13x equals 104. Divide by 13, and x equals 8. Okay, again, they want us to find angle 2. So we know that angle 2 is 7x minus 11. So 7 times 8 minus 11, and that would equal 45 degrees. Okay, last question. Now we're taking more of a word problem scenario, but taking a sentence and turning it into an equation. So when you have questions like this, I want you to break it down into parts and look for those key words. The first thing that I see is angle is. Anytime you see the word is, that means equal. And if we're looking for the angle over here, it says find the angle, then that means the angle is just x. That's who we're looking for. Then I see 57 more than. Well, I know more than means plus. And so if you have the word than added to it, that means stick that at the back. So put it at the end. You're going to do something and then add 57. So I'm going to represent that as plus 57 with a little arrow to remind myself. It's got to go at the back. Then I know that twice means 2 times something. And complement, we know, deals with 90. Anytime you're looking for a complement, if you know one angle, all you have to do is subtract that number from 90 to find its complement. So anytime you see the word complement, you would stick 90 minus x in place of it. So now let's put all that together and say x equals, we know 57 is going at the back, so we would say 2 times the complement, 90 minus x, plus 57. And that's your equation to solve. So let's distribute the 2. So x equals 180 minus 2x plus 57. Let's move the 2x over. So we have 3x equals, let's combine our 180 and 57, giving us 237. Divide by 3, and x equals 79 degrees. Now, the question says find the angle. Well, we said the angle was x up here at the top, so that would be your final answer. One thing that I want you to add to your notes before we finish is this right here to help you with these types of problems. Anytime you see the word complement and you're having to write an equation, you're going to stick in the expression 90 minus x. Anytime you see the word supplement in an equation, you can substitute 180 minus x. And so if you'll remember that, then these equations become very easy. So just when you're working through today's lesson, think about your vocabulary word and then use the equation that I gave you in the video to help you solve the problem.